Today we are going to see about existence theorem in ordinary differential equation. The statement for this question is for any real x naught and constants alpha beta there exists a solution pi of the initial value problem L of y equal to 0, y of x naught equal to alpha, y dash of x naught equal to beta on minus alpha less than x less than alpha. It is either alpha or infinity. For any real x naught, whatever the number belongs to x naught, that is a real, and alpha and beta are the constants. So there exists a pi of the initial value problem. So consider the equation L of y equal to 0 means for initial value problem it should satisfy the conditions and also the differential equation. So that differential equation is written in the form of L of y equal to 0, and the conditions are y of x naught equal to alpha, y dash of x naught equal to beta. So what we do means we have to prove that it is a C1 C2 or linearly independent. That means C1 C2 has a unique constant, so we have to show that there are unique constants C1 C2 such that, so for example L of y equal to 0 means there exists a solution that is if L of y equal to 0 means L of y equal to 0 means if pi is a solution, then how we write means L of pi equal to 0. Every solution can be written as a linear combination. Here we took a second order, so that is C1 pi 1 plus C2 pi 2. It should satisfy the, if pi is the solution, if L of y equal to 0, if pi is a solution means then L of pi equal to 0. For that, instead of y we have to replace the pi. So here it is y of x naught equal to alpha. For that y we have to replace pi. So pi of x naught equal to alpha and pi dash of x naught equal to beta. So we know that if pi 1 pi 2 if pi is a solution, then the pi 1 pi 2 are also a solution. So the solution exists in the two forms. So if the roots are, that means if we take the second order equation, there exist two roots. So what is the power of degree, power of that equation means that much root we will have. So for that if we take a second order equation means we have two roots. So that roots may be a distant or maybe may not be a distant. So if r1 not equal to r2, the condition r1 not equal to r2 means we write pi of 1 equal to e power r1x and pi 2 of x equal to e power r2x. If r1 equal to r2, both are equal means what we do means pi 1 of x equal to e power r1x, pi 2 of x equal to x into e power r2x. So we know that from the equation we know that pi equal to c1 pi 1 plus c2 pi 2. So pi is nothing but with respect to x, so pi of x equal to c1 pi 1 x plus c2 pi 2 x. So instead of there is a x, for any real x naught if we substitute any value means pi of x naught equal to c1 pi 1 of x naught plus c2 pi 2 of x naught. We know that pi of x naught equal to alpha, we already assumed that. So alpha equal to c1 pi 1 x naught plus c2 pi 2 x naught, and pi dash of x naught is beta. So if we differentiate the function pi 1 means we get if we differentiate this means pi function means pi dash of x naught equal to c1 pi 1 dash of x naught plus c2 pi 2 dash of x naught. So for that pi dash of x naught we know that that is beta. So the simplified form what we get means this term, that is c1 pi 1 x naught plus c2 pi 2 x naught. Instead of pi x naught we know that that is a alpha, so we replace it as alpha. And then for pi dash of x naught if we differentiate the term means, and we get pi dash of x naught equal to c1, there is a constant, this is the function. So if we differentiate means we get only pi 1 dash of x naught plus c2 pi 2 dash of x naught. So pi dash of x naught we know that that is a beta. So the simplified of equation is c1 pi 1 x naught plus c2 pi 2 x naught equal to alpha, and c1 pi 1 dash x naught plus c2 pi 2 dash x naught equal to beta. This is the simplified equation that we get in the existence theorem. So we have to prove that the unique solution. For that unique solution we have to prove that the determinant not equal to 0. If the determinant equal to 0 means there must exist infinitively many solutions. If the determinant not equal to 0 means there exists only a unique solution. For that we have to check the determinant equal to in this determinant we have to use only a function terms. So here function is nothing but pi 1 x 0, pi 2 x 0, pi 1 dash x 0, pi 2 dash x 0. So we have to substitute pi 1 x 0, pi 2 x 0, pi 1 dash x 0, pi 2 dash x 0. So if we take a determinant means we cross over pi 1 x 0 into pi 2 dash x 0 minus pi 1 dash x 0, pi 2 dash x 0. So it must be not equal to 0 means only there is this unique solution. For that we have two cases, either the case 1 r1 not equal to r2 or the case 2 r1 equal to r2. If we take that r1 not equal to r2 means we have that condition, that is pi 1 of x equal to e power r1x, pi 2 of x equal to e power r2x, and we have to differentiate one more time. Pi dash of x equal to, if we differentiate with respect to x means r1 e power r1x, pi 2 dash of x means r2 e power r2x. So if we substitute the values pi 1, pi 2, pi 1 dash and pi 2 dash in the determinant conditions, so here it is pi of x 0, pi 2 dash of pi 1 of x 0, here pi 2 dash of x 0. So pi 1 of x 0 is e power r1 x 0, pi 2 dash of x 0 is r2 e power r2 x 0. So here having a x terms, we are choosing a x 0 because it is a real value of x 0. So instead of x we have to replace x 0 minus what is the here pi 1 dash x 0, pi 2 x 0. So pi 1 dash x 0, pi 2 x 0 is r1 e power r1 x 0 plus e power r2 x 0. So if we take the e power r1 x 0 as a common means what we get means r2 minus r1 e power r1 x 0 and into e power r2 x 0. So if we get this terms, if we take e power r1 x 0 and e power r2 x 0 as a common means we get r2 minus r1. So this terms e power, if r1 r2 not equal to 0, we know that if this terms, if r1 equal to 0 means also e power 0 is e power 0 is nothing but 1. So this term not be 0, so it is uniquely determined. For that uniquely determined, for that the next condition r1 equal to r2. So pi 1 of x equal to e power r1x, pi 2 of x equal to x into e power r1x. So our pi dash of x, if we differentiate means r1 e power r1x, pi 2 of x means if we differentiate means this is in the form of uv format, u v dash u x, and v dash is r1 e power r1x plus v u dash means e power r1x into x is 1. So if we substitute the conditions, what we do in the, it is instead of pi 1 x 0, pi 2 dash x 0, that is pi 1 x 0, pi 2 dash x 0 means we get this values minus, and pi 1 dash x 0, pi 2 x 0 means we get this value. So if we take the if we multiply this e power r1 x 0 into inside means we get this values, and if we take the common this terms and this terms are getting cancelled, and if we add the base is common, so we have to add the powers e power r1 x 0 plus r2 or r1 x 0 plus r1 x 0. If the addition we get means e power 2 r1 x 0. So the e power r1 and r2 are equal means if we put r1 equal to 0 means e power r1 is r1 e power 0 equal to 1. So there is the determinant either be 0. So the determinant condition is satisfied in either case. Both the cases the determinant is not equal to 0. So the function c1 pi 1 plus c2 pi 2 is the unique solution, where c1 and c2 are the constants. Hope you all understand, and thank you.